And welcome back, everyone. Let's carry on with the next thing, working with Wise. All right. So, a landscaper wants to plant grass onto again, we take note of the shape, rectangular sandy patch of land. The grass is cut into square pieces measuring 1 meter by 1 meter. How many squares of grass are needed to fit along the width of the sandy patch? All right, so the width, the breadth, similar thing. So what we've got to look at now is the width, and I'm going to mark it off on this side. The width is measured by this line, and that line measures 3 meters. So if I put in a piece of grass there, you agree that that little line that I've got there actually takes up that little space of the 3 meters. And if I put another piece of grass next to it, that piece of line would then take up that piece, and so on and so forth. So what are we actually doing? We're trying to see how many times one of these little pieces, okay, fits into 3. So what's the calculation? All right, we've got to go 3 divided by 1, we can get in 3 squares across that patch. Nice work, well done, very well done. So, David wants to wrap, let's get the diagram out. David wants to wrap 4 candles into a rectangular box. Calculate the diameter of 1 candle if the width of the box is 15 centimeters. Okay, so David wants to wrap 4 candles. So if this is going across the width of the box, then the candle will go that way. That's 1 candle. And then if I place another candle next to it, I'm going to try and draw a circle here. Let's say there's another candle. Then what's happening? The diameter is going across this way as well. And how many of these candles do we have? We have 4 candles. So we have 4 diameters in length that are next to each other. Do you see that? So how do I calculate this? What I've got to realize is each one of those takes a part out of the 15. Therefore, all right, 15 divided by 4, and that gives me 3,75. Now remember, maths rote rounding. If I round off here, if I round up because of the 7, I get 4. But is that the right answer? No. That's saying we can fit in an extra candle, but we can't actually do that. So this is actually 3 centimeters. All right, nice work. Okay, let's carry on. So looking at the next piece, packaging. So packaging involves figuring out the amount of a small shape that can fit into a larger shape. That's what we're going to try and do here. See how many times this little shape can fit into a larger shape. Like the socks inside that box. All right. So a landscaper wants to plant grass onto a rectangular sandy patch of land. The grass is cut into square pieces measuring 1 meter by 1 meter. How many squares of grass are needed? All right. So if I look at this, I can fit 9 squares lengthwise. If you think back from the previous questions, we said we took 9 divided by 1. My answer was 9 squares of grass. So let me just call them squares. Nice. Then we said that we could fit 3 of those lengthwise because previously 3 divided by 1 gave me 3 square. Ooh, that's a bit of a scribble. There we go. That's much better. Squares. All right. Remember, we spoke of this line's relation to that piece. All right. That's what we were talking about there. Now, how many squares of grass are needed in total? So then 9 times 3 gave me 27 squares in total. So if you got all those little squares, they're going to give me 27 in total. Because what did we do? We took the amount of squares lengthwise, we took the amount of squares widthwise, so across the length that way. All right, across the length, the width again, sorry, this way. And if we multiply the two, we get all of those squares that covered up the whole sandy area. Very nice work. 27 squares in total. All right, so making good progress. Sipo wants to pack rectangular gift boxes into a large rectangular box. Would he be able to fit more boxes in if he arranges them lengthwise or widthwise? All right, so to start off here, what we notice is this rectangular shape measures 500 centimeters by 80 centimeters. The little box he has a length of 10. So what do we know? For the length, we know that the length of 10 here is going to fit across here. So let's say that's one part of 10. Let's say it takes up that spot. Then we go to the next part of 10, it takes up that spot. And so on and so on and so on and so forth until all 500 centimeters is covered. So what do I need to do? I need to figure out how many of these boxes fit into 500. What does that mean? Fit into means to divide. So 500 divided by 10 gives me 50 boxes. Excellent. So we can fit 50 boxes lengthwise. Now we've got to figure out how many boxes we could fit widthwise, then we can decide which is the better fit. So this way, looking at this, all right, same question, but the width now, there, that is 8 centimeters. Where's that going to fit? Across its width, across this piece, so 8 there, and then maybe another 8 there, and so on and so forth, until all 80 is covered up. So what have I got to do? I've got to take the 80, so this is the width, and what must I do to that? That's the total length. I've got to divide it by 8, so I can figure out how many boxes can fit across its length. And in this case, that was 10 boxes. All right, if we go back, we remember the length. All right, the length was 50 boxes. Okay, so to answer the question, would he be able to fit more boxes if he arranges them lengthwise or widthwise? Which answer is bigger, 10 or 50? 50. So my answer would be, therefore, lengthwise is better. So lengthwise fits and more. Aha. Thanks everyone for tuning in today. I hope you guys learned something. Until we chat again. Take care. Goodbye.